Hello, this is another National 5 Maths video, and in this video we are technically on the topic of statistics, but we're talking about scattergraphs, which really is a straight lines topic as well. So it kind of is a merger of statistics and also the straight line equation process. So scattergraphs are used to display statistics, to display data which are related to each other but cannot be described perfectly by a formula. And they're used to show a correlation. So how a scattergraph looks like, you get two here. It's basically just dots that represent the data points. And what we use scattergraphs for is to just get a general idea of the trend. So the one on the left is a comparison between height and weight. And if you think about kind of real life people, the bigger height you are, generally, the more you would weigh because there's more of you. So there would be a positive correlation, and that's represented in this straight line, which is called a line of best fit. So the line of best fit is the kind of important thing here. That's the thing that you're going to try and find the equation of. There's a negative correlation would look at the right hand side. If you think about a car, on the y-axis we have the car value, on the x-axis we have the miles driven, and also that's just common sense. The longer you drive a car for, the less valuable it is. So as miles driven goes up, value actually goes down, and then you get this straight line with think of it like a negative gradient. That's exactly the kind of idea. You would get a negative correlation here. So this line of best fit, how we actually, if you've done Nat 4 Maths, you recognise these questions. You have to actually draw one of these in Nat 4 Maths, where you are trying to just draw the line through the middle of the data points as much as you can. So it's a straight line and it's trying to go through the middle, cut through the middle of the data points. So all we're actually really doing here is finding the equation of a straight line, but it's a wee bit different. Usually it will not be coordinates given to us, it will be real life kind of situations, and you have to pick out one of the dots that you can accurately get an x and a y coordinate from. Commonly different letters will be used to represent the x and y axis, so it might be height and weight, so W and H, or miles driven and value, so maybe M and V, and you have to usually give your equation in terms of these letters, and that's a common mistake that people miss out, is to change the letters from Y and X to whatever they are in the question. We'll see that in a minute. And then part B will often ask you to then use your formula that you've worked out to then estimate a value. So basically it's just a substitution into your formula. That's pretty easy, and again we'll show you an example of that in a second. So let's have a look at this particular question, which is the power of an industrial battery, which is represented by P, which is the y-axis, but it's now the p-axis technically, and it's the power after t hours of charging. So if we look at the graph here, we have P along the y-axis, T along the x-axis goes from 0 to 40 hours of charging in terms of the t-axis, and it goes from 0 to 60, I think it doesn't say, but I think it would be maybe watts in terms of the power, unit of power. We've got all these data points, the kind of red squares dotted about here. That's a scatter graph, and what has been drawn is a line of best fit. So there shows that there's a positive correlation here. The longer you charge it for, the more power the battery has. And our job is not really to understand the data, our job is to find the equation of this line of best fit. Okay, so here is the important bit, is that you are not actually paying any attention to the dots. You're paying attention to where the line goes through a corner. So if I show you what I mean, this line goes through the corner of, where we can easily find a coordinate at that point there, and and at this point here. So we can see clearly that the line goes through the point 10 along the bottom, and then 30 along there, and it clearly goes through 20, 50. So this is the first kind of hurdle with these questions, is actually to figure out the correct coordinates to use. Now, because this line actually does extend to the y-axis, down here at 10, you could actually also use 0, 10, but it won't always do that, so I'm not going to use that one, but you could use that one. You could use 0, 10 with one of the other two to get your equation. So find the equation of the line in terms of P and T. So we're back to straight line, we're finding the equation of a line, so we need the gradient and we need to sub in a point. So let's write down our coordinates. So it's 10, 30, which we're going to call x1 and y1, and then it's 20, 50, x2 and y2. Now the other difference between these questions and just a standard straight line question is often the numbers are going to be bigger because it's talking about real life stuff like the value of a car. So it could be in thousands, which don't do a lot of for working out your gradient. So you just need to be careful with your numeracy skills here. So we've got y2 minus y1 over x2 minus x1. So y2 is 50, take away 30 over 20 minus 10. So that's going to be 20 over 10, so that is going to be a gradient of 2. So pick easiest point, we're going to pick 10, 30. Technically 0, 10 would be the easiest point, but we're not going to use that one just now. So we've got that as A and B, and we've got our gradient of 2. And we're just doing the same thing as we would in a straight line question. We're subbing those into y minus b equals m bracket x minus a. So it's going to be y minus 30 equals 2 bracket x minus 10. So y minus 30 equals 2x minus 20. So y, if we put the minus 30, if we add it to both sides, so it's going to be minus 20 add 30 is 2x plus 10. Now you've done all the maths correct up to this point, but you won't get the last mark unless you change your y and your x into the proper letters in your question. Remember, the y-axis is not the y-axis in this question, it's the p-axis, so change your y to a p, and the x-axis is t. So last mark for remembering to change your letters to p equals 2t plus 10. Okay, now part B is going to look pretty similar for every type of question. It will say use your equation to estimate the power of a battery that has been charged for 60 hours. So all this is taking your value of t, or taking 60 and putting it in for t. So it's literally just doing 2 times 60 plus 10. So it's just a substitution question and just work out the value. So 120 plus 10. So 130. We're not given the units, but watts, possibly, doesn't really matter. As long as you've got the right number. You won't need the units. You're not gonna mark down if you don't have the units. So just get the numbers correct. So remember, even if you do not have the correct equation, if you've made a little mistake somewhere in part A, as long as you substitute into the equation that you have in part B and you do the numeracy right there, you can still get that last mark.